So when we get to the Bohr model, we get to a model which is pretty darn useful. 33. Yes. That was charming. Page 33. So, who is the model before Bohr? Rutherford. Okay, so there was Dalton, who did the billiard ball. There was Thomson, who discovered, what particle did Thomson discover? The electron. And then everything else was positive. And then we had Rutherford, who said, oh, good, you found it. Excellent. I meant to give it back to you at the beginning of class and I totally forgot. And then we had Rutherford who said, no, the positive isn't everywhere. It's in the middle. And then he said the electrons were just sort of around the outside. And then we got to Bohr, who had something very specific to say about where the electrons were. Yes, they're outside of the, what do we call that center bit? The nucleus. What particles are in the nucleus? Tell your partner, what particles, what subatomic particles are in the nucleus? Those are your protons and neutrons. But now we're going to get into what Bohr said. And we're not going to talk about Bohr's experiments because they're a little bit above the grade 9 level. If you are interested in doing some enriched stuff, you can take a look. I got a little carried away. You don't have to do everything in here. You can just like sort of either do 9.1 or 9.2 or the little first part of 9.1 and the first part of 9.2. So if you're interested, the enriched stuff is here, and it does get into Bohr's experiments a little bit, okay? But we're not going to talk about Bohr's experiments very much because, like I said, they're a little bit complicated. But what he said is he said that around the nucleus, there were these energy levels, okay, which are also known as shells. So you can see it's like a shell. There's this circle around there, and that's where the shell is. And he said that is where electrons live. Electrons live on an energy level, okay? Electrons live on an energy level. What's the other word for energy level? A shell. Okay, so you can see here, in this picture, we have our nucleus, which is positive because of the protons. And then around the outside, we have shown how many shells? How many shells are in this picture? Okay, you guys are killing me. Count the circles. There are 3. Yes, 1, 2, 3. Now, there's actually more than 3 shells, but I just want you to be aware these little circles around the outside are called shells. And what Bohr said was really, really interesting and weird, okay? He said electrons can only exist on those shells. Okay? And this doesn't sound weird yet, but bear with me, it will get stranger. So you can have an electron here, or you can have an electron here, but you cannot have an electron in between the shells. So having an electron in between shells, that is a big no. No electrons can exist in between shells. And maybe that doesn't sound like a big deal yet, but it will, because I'm going to tell you something that's going to make this very strange. Electrons move from one energy level to the next energy level. They can hop up further away. So you could have an electron move up. You can have an electron move down, as long as there's space. But here's the thing, they don't pass through the space in between. They are simply in energy level 2, and then they're in energy level 3, or they're in energy level 3, and then they drop down to energy level 2, and they do not pass through the space in between. It's a little bit like that. We will talk a little bit about how they do it, but you're not really expected to understand it because, quite frankly, even the biggest brains in the world were not entirely happy with how electrons really are. Okay? We're going to stick with the Bohr model for grade 9 for the most part, just because it's pretty nice. We're like, okay, there's electrons on shell number 1, there's electrons on shell number 2. We're not going to worry about how they move from one to another. Okay? We'll talk about it a little bit just to whet your appetite for interesting things if you want to take some enriched chemistry in grade 11 and 12, but you don't have to worry about it. All you need for grade 9 is that the electrons can live only on an energy level and they cannot be in between. Okay? And that's it. That's all you need to know. Now, electrons are, what charge are electrons? Negative. The nucleus is, what charge is the nucleus? Nucleus is positive because it contains protons which are positive. And what charge are neutrons? They are neutral. Neutrons are neutral, okay? So we have, our nucleus. I need an S on the nucleus. What do negative and positive do to each other? They attract. So if you were an electron and you had a choice between living on shell number 1 or shell number 2 or shell number 3, if you were an electron and you had your choice of any of those, where would you like to live? Remember, you are negative and the nucleus is positive. Where would you like to be? Number 1, because the nucleus pulls you in, okay? You find the nucleus extremely attractive, okay? So, the first electron in any atom is going to go into shell 1 because it's closest to the nucleus. I almost like to think about it like an apartment building without an elevator, okay? So we got an apartment building without an elevator. And let's say we've got floor number 1, we've got floor number 2, and we've got floor number 3. Now, on floor number 1, we just have one room, okay? One room. And one room can hold 2 electrons. We good so far? Okay. You don't have to draw this little picture. If it's helpful to you, you can, but you don't have to. So I can put in 1 electron and I can put in 2 electrons on the first floor. And now all the rooms on the first floor are full because there's only 1 room on the first floor. Maybe there's a gym down there taking up the rest of the space. I don't know. Something like that. Yes? But if there's no elevator in this building, would you like to live on the first floor, the second floor, or the third floor? There's no elevator, and you have to carry groceries in every day. First floor. Let's just assume that you have to carry a piano into your apartment every day. Okay? You play the tuba, and you need to carry your tuba to your apartment in and out every day. Where would you like to live? First, second, or third floor? First floor, because you don't have to lug a tuba up, 3 flights of stairs, okay? It's an analogy. It's not perfect, all right? Now, on the second floor, there are 1, 2, 3, 4 rooms. On the second floor, we have 4 rooms, and each room can contain 2 electrons. So how many electrons can fit on the second floor? 8. 1, 2, 3, 4, 5, 6, 7, 8. And the third floor also has 4 rooms. 1, 2, 3, 4, 5, 6, 7, 8. So we can have 8 electrons on the third floor, 8 electrons on the second floor, and 2 electrons on the first floor. Yes? Now, these apartments, these floors, those are like the shells. Okay, so shell number 1, how many electrons can shell number 1 contain? 2 electrons. How many electrons can shell number 2 contain? That's like our second floor. 8. And how many electrons can our third shell contain? There's 4 rooms. Each can hold 2 electrons. How many electrons can live in the third shell? 8. You guys are killing me. Oh my God. So we have a maximum in shell number 1. Ooh, I misspelled maximum. It says maximum. Maximum. Okay, I need to fix that because that's not right. So the maximum number of electrons in shell number 1 is 2. In shell number 2, it's 8. And in shell number 3, it's 8. Now, shell number 4, really the Bohr model falls apart. The Bohr model doesn't work very well after we put 2 electrons into shell number 4. In theory, it can kind of hold 18, but we would not draw a Bohr model for something that has more than 20 electrons. Okay? The Bohr model is not so good above energy level 3. Above shell number 3. And that's why I've got it in brackets with a little star beside it, because it's like maybe it contains 18. Maybe in grade 10, your teacher will teach you that it contains 18 electrons. Maybe they won't. I don't know. You've been introduced to the concept, so there we are. We're only going to be dealing with the first 3 shells, and we will have a 4th shell, but we'll only put 2 electrons in at maximum. It can hold more than 2, but we're not going to draw anything past that. Okay. Now, let's remind ourselves about our periodic table. Go get your yellow periodic table. Get your periodic table out. Stop drawing pictures. Get your periodic table out. You're going to draw pictures, but you're going to draw Bohr models. Okay? Turn to page 33. Boys, you may not sit together unless you're on page 33 and you're paying attention. Yes. So we've got a lithium atom. Look on your periodic table. Here's lithium. And you'll notice the number at the top says 3. Do you remember what that number at the top tells us? It's the atomic number, and the atomic number tells you the number of protons. So if you want to write that on your periodic table, you can write that on your periodic table, that the atomic number tells you the number of protons. Nick, are you paying attention or are you doing something else? Just asking. Okay. So, atomic number is the number of protons. Atoms are neutral. So let's go back here. Okay. So number 3, that's the atomic number. That's the number of protons. Kai, can you move over here, please? Thank you. So how many protons do we have? We have 3. Now, that's a weird 3. We have 3. Atoms are neutral. So if we have 3 protons, what's our total positive charge? Each is +1. We have +1 and +1 and +1. What's the total? 3. So we have 3 positive charges. How many negative charges do we need to make it neutral? How many negatives do we need to make it equal 0? 3. So we need 3 negatives. And that means what particles are negatives? Electrons. So if we have the atomic number and the protons is 3, then we also need to have 3 electrons. Yes? So in a Bohr model, in general, in the nucleus, we write the number of protons. So we've got 3 protons. At this point, I would have to tell you the number of neutrons. In this case, there's 4 neutrons. That's the most common version of lithium. And we have 3 electrons. Now, do you remember what I said about the rooms? Here's room number 1 on floor number 1. Floor number 2 has 4 rooms. 1 room is at the top, 1 room is at the side, and 1 room is at the bottom, and another room is at the other side. So you can think of this like a room. Shell 1 has 1 room. Shell 2 has how many rooms? 4. Shell 1 has 1. Shell 2 has 4. How many does shell 3 have? 4. Okay. And where do the 4 rooms go? One goes on the side, one goes on the other side. Okay, so that's where our rooms go. So you can see, where did the electrons go? They went into the first floor, and then that room was full. And so the 3rd electron has to go onto the 2nd floor. It doesn't matter whether you put that electron on the top or on the bottom or on either side. It really doesn't matter. I like to start at the top and work my way around clockwise because it keeps me organized, but you don't have to. Okay? So that is how we would draw a Bohr model of lithium. Protons and neutrons in the nucleus, 2 electrons on shell 1, 1 electron on shell 2. Let's try something bigger than lithium. We're going to try nitrogen, and I know it's there for you, but I'm going to draw nitrogen over here. We have, in the nucleus, we have 7 protons, and I'm just going to put 7 neutrons. Again, you don't have to know neutrons at this point. How did I know that nitrogen has 7 protons? Because its atomic number 7. And what do we know about atoms? Atoms are neutral. So if we have 7 positives, how many negatives do we need to have? 7 electrons. So now what we're going to do is we're going to put our electrons onto our Bohr diagram. And here is the nucleus. I'm coloring the nucleus in yellow. How many rooms on shell number 1? 1 room. So out of my 7 electrons, I can put 2 electrons into there. How many electrons do I have left? I got 5 left, so I'm going to have to start on shell number 2 now. How many rooms on shell 2? 4. 1 at the top, 1 at the side, 1 at the bottom, and 1 at the side. So I'm going to start at the top, and I'm going to put 1 electron in. Let's assume that electrons are like strangers. Okay? Maybe this isn't an apartment building. Maybe it's a hotel, and you're checking into the hotel. Yes? Would you rather check into a shared room, or would you rather check into a room by yourself? You'd probably rather check into a room by yourself. Sharing a room with a stranger, yeah, if you're traveling through, Europe or Asia or something, and you're going to some hostels, right? Youth hostels. It's a cheap way to go. You might have like a dorm room, but probably a room to yourself is nice. So we've got 1, 2, 3. We're going to put our 4th one in a different room. Yes. Oh, no, you didn't have your hand up. You were just moving your arm. Sorry. Okay, so wait, 1, 2, 3, 4. Where should I put the 5th one? 5. That's 5. And then I need to put 6. And where does the 7th one have to go? At the top. Okay, so I just go around the circle clockwise and put 1 in each, and I only pair up when I have to. Is good? Where do you start? At the top. Show me which way you go around. I got 2 people doing it, 3 people, 4 people, 5 people, 6, 7, 8. Everybody show me good, okay? You go around clockwise. So start at the top and then put 1 in each space. And then if you need another one, you're going to put a second one in there, and then you can double up until everybody's full. And that's how you draw Bohr models. Okay? So here's a little picture of the Bohr model. Our first floor has only 1 room. The second floor has 4 rooms. The third floor has 4 rooms. The hotel has no elevator. Oh, this is why the elevator's good. And you have lots of luggage. So electrons will fill the lower floors first. Each room can accommodate 2 electrons. They're only going to go in 1 at a time. And I like to go around clockwise. So let's try oxygen. And at the top of oxygen, it says 8. What does that 8 mean? First of all, what do we call that number? That number is called the, tell your partner. It's called the atomic number. What does it tell you? The number of protons. And if we have a neutral atom, it is also the number of electrons. Yes. Yeah. So, how many protons will go in our nucleus? For oxygen, 8. And we have some neutrons. We'll worry about how many later. Actually, we'll have 8 for this one. Don't worry about how I found that. It's not always the same as the number of electrons. How many electrons in shell number 1 for oxygen? 1, 2. So now we've used up 2 electrons. If you're drawing it yourself, you can draw these little boxes in. You don't have to draw the boxes, though. The boxes are not necessary. The boxes are there to help you out if you need it. But if you don't need it, you can just draw the electrons. Okay? 1, 2, 3. Where does 4 go? Where does 4 go? On which side? The right side. 4. Where does 5 go? Bottom. 6. Left side. 7. Top. 8. Right. And we're out of electrons because we had 8. And that's it. Is good? Okay. Now, you don't need to really know this, but this just shows you that number 1 goes here, 2 goes here, and then you have 3, 4, 5, 6, and then they start pairing up 7, 8, 9, 10. And you do the same thing on the next shell and the same thing on the next shell. Take a look at shell number 4. Shell number 4, I only show 2 rooms because we're only going to place 2 electrons maximum because Bohr models only work up to element number 20. After that, the Bohr model is not very useful. Okay, so we don't have to worry. There's a lot more rooms on shell 4, but we are not going to fill them up. Okay, it's like maybe that part of the hotel is under construction. Right? There's a lot more rooms, but you're not going to use them. Okay? Shell 4 has a lot more rooms, but we won't use them. Is good? You're here to do a survey? Good stuff. So a couple of you guys can do surveys. Otherwise, start working on the exercises on pages 36, 37, and 38. Pages 36, 37, and 38. Yes, you can grab the enriched stuff, yeah.